Okay, so now that we, in the last one, got our scene kind of blocked out, what we're going to end up doing now is we're actually going to go through here and make sure that we can do some static lighting on this scene. So the first thing before we even bake lighting, as you can see I have this error right here, lights need to be rebuilt. I'm going to check to see what the light map resolution is. If you don't know what light mapping is, you can check out my YouTube channel. I have a video on there on it, but also my course on Udemy for beginners lighting. That would be a good help for you. So what we have here is light map density, and we can see that blue, anything that's blue, basically in Unreal's term is something that is a bit too low in terms of its intensity. So if you think about this cube's green. Unreal considers the number of squares, which I'll explain in a second, to be at the right density, and these ones that are blue, each one of these squares is too few squares. So what do these squares mean when I went to this light map density? Well, each one of these squares actually represents a pixel. And you might be thinking, what? That's really low res. Because imagine your monitor, how many million pixels you have in total by even on a 1080 monitor. And yeah, it's too low. So what do? So what we need to do is we need to go in the mesh. When we select it in newer versions of Unreal, it turns pink. Not sure why. I think it's just to let you know what you have selected. I think it actually makes it hard to see your if you're in the right ballpark. So what we're going to do is we're going to select that mesh, and I'll explain here in a second. Go to the details, and you're going to see lighting, override light mass res setting right here. So we'll turn that on, and as you see, if I left click and scroll on it, it's changing its intensity. Now here's why I don't like that it turns pink, because let's just say that that's roughly right. I have to click off the exit or hit escape to see if it's right. And technically Unreal still thinks it's a little low because it's not like the right color of green, so I'm going to go a little more, and there. So that's about right. And to expedite this process, I'm just going to roughly grab everything that looks kind of egregious and just real rough come in here, override. And you can't click and drag on multiple meshes, but let's just put 1,000 in and then unclick and kind of take a check. So now what we see is that green is best. Green is what Unreal considers to be about right. If you need more, don't worry if it's orange, especially if it's baked. It's just going to take up more texture memory. But what we can do is we can always click these two and just put them back down to like 800 or 600, and that's about right. Again, we're not trying to be perfect at this stage. We're just trying to get some things mocked up. So I don't want to go too crazy, but let's just put like 400 on that. You're not going to see in there too much. Okay. Anything else I'm missing? That's the end sort of that closet. We don't really care about the end of that too much. This ramp probably could just use a little more. It's pretty small mesh too, so let's just go with like 200 to start. Yeah, that's great. Hit escape, it just drops the tool. And when I'm done with that, I'm gonna come back to light map setting, density, go to lit mode. This is what our level still looks like. And I'm gonna grab the directional light for now, and I'm gonna rotate it. And I wanna get, you can see I had this little slice right here. I'm gonna play with like this kind of like, I don't think I like the way that slice comes into that room like that. So maybe I'm gonna make the angle a little more extreme, something like this. And what we can do is, again, the ceiling in the reference has kind of a hole here, so some light leaks down through, and that could be kind of cool. So let's just build this. So I'm gonna click build, and it'll vary how good your computer is, how long this should take. We're also probably going to be baking most likely here in preview. What does that mean? We hit this build button. It builds a bunch of stuff, but the primary thing we are interested in is it's building the lighting. And under your lighting quality right here, this is basically how accurate your light is going to be. So imagine on production, the light in your scene, light is this kind of ray / wave thing that bounces around a lot. So on preview, it bounces around a lot less. And on production, it bounces around a lot more. So if you want the really best results, you want to set this to production. The problem is it's pretty expensive in terms of time. So if you're not too worried about just getting some tests early on, okay, so this has finished. So, and you can notice because I was kind of messing around in a different window, it didn't apply, so I want to apply now. And this should, hypothetically, as long as I didn't goof anything up, it should be lit. And if I scroll back up, this is all good. This is lit too. And we're just starting to see some of the results. And so you might be asking yourself, okay, well, that's not great. First of all, I got this like shimmery thing here, Z fighting. It's way wicked white. What's going on with that? Why is it so dark compared to this one? What are some other things? It's F11. We got a few things. Let me get this out of the way. If you hit G, you'll go into game mode. Oop. Let's go to show, use defaults. I had some volumetric light probes on. And some things you'll notice. So first and foremost, we get kind of like a shadow in the corner. Now, don't be fooled. There's some things that can change on that. That could be screen space AO, which is what my guess is. It's probably not actually the real AO bake. So we baked. Why is it not great? Well, how can we make it better? Okay, well, a couple things are gonna make it better. First and foremost is, let's scale this one down so that they're not overlapping. Just for now. What you would really want to do is come in here and actually set them to be grid snapped. Again, when we actually do the real one, we can change that. What I'm going to also do is I'm going to scale this mesh down. What's happening is it was a lot brighter, and it's because light was hitting on the outside edge of this mesh and literally sucking light across because the resolution was too low. So the whole thing kind of brightened up. So pro tip, if you've ever got a mesh that kind of goes outside a wall and one on the inside and it's too low res, it's not going to actually light the way you would expect. And I think instead of like making this snap look perfect, I think I'll just do something kind of artsy here and leave an obvious gap so it looks kind of cool until we go through here and actually do this right. So the next thing we want to do is what we didn't do last time that's important for quality lighting is we need to add a light mass importance volume. And unfortunately, the default scene doesn't come with one by default, which is kind of sad, but if you come over to your classes, we'll do light mass importance volume. I'm gonna drag that in. And from here, the long short of it, this cube is kind of an influence volume. And so what that means is we want everything, so I'm going over to the brush settings, I'm just left clicking and dragging. We want everything that's in our level that we care about having quality lighting on inside this box. And why is that? Well, the engine, in terms of a performance gain, looks at this box and says, anything inside this box, I want you to do higher quality calculations. Because you can imagine this Unreal scene is actually basically infinite. There are limits because of math and floating point number error and whatnot, but in not so many words, it's basically infinite. And so we have to decide where to spend our time on quality samples for our lighting. So putting this box in, super duper duper important. When we just box it around, click Control S to save our level so we don't lose our work. And again, I'm going to click build. Still building on preview. We're not too worried about building on production yet because we don't really care about how long that takes. We're more interested in just getting through some of these generic things that we want to see and make sure that are working. Now, as this is building, the next thing I know we're going to need to add is a reflection probe. I think they have one in there by default, yes. So when you make a default scene, you new level, and you use the blank template, the one that we have here with the sky. Sorry, not the true blank one, but the one that has the starter. If we search for reflection probe, we get this little bad boy. So as this is baking, I'll explain. This cube right here basically is a 6-sided camera. Takes a picture up, down, left, right, forward, backwards, stitches them all together, and that ends up making basically a sphere image that all these surfaces, as long as they're within this influence, so this is kind of its bounds, it just happens to be a sphere, we'll use those for their reflections if we get a certain distance away. So if you got something in your level that's shiny and you don't got one of these, you're not going to see it. And so the position of this also matters. If we move it, it breaks everything. So don't do that quite yet. Now, let's take a look. Now, what have we done? You notice we got much better quality shadows going on now. We've also fixed that egregious shadowing difference from outside to inside. Again, like kind of how I told you, be careful with meshes that hang out too far, especially if the lighting is way different. Super bright out here and dark inside there. The next thing I like to do, after we made sure that we checked that our reflection probe here isn't buoyant, and it's in a good spot, I put one pretty localized. So this is like the main area you can think of as you walk in, so that's probably pretty good. It's got all of our meshes for this, let's call it, area of our map. Imagine we made another area back here, we'd add another reflection probe to it. What I like to do is control the camera a bit more, because you can think of the thing we're looking through as a virtual camera, not necessarily human eyes, even though that's what it's simulating right now. And when we take a look at this right here, cameras let light in with exposure. They do it through a couple different things. The things that control how much light gets into the camera is how big the opening on the camera is, how long that opening is open for, and then the sensitivity of the film, the thing that the light is hitting. Those three things combined let you know how bright your image is going to be. Now, in our eyes as humans, we basically just have an aperture. We have our pupil opens bigger to let more light in. The sensitivity of your eye is about this. It doesn't change. It's not dynamic in that sense. But based on how big your pupils can dilate, we'll let more or less light in. And what you're kind of seeing here is if we uncheck this, we are going to what would be like a camera. So right now, when we uncheck this exposure game settings, and I'll explain where that's being set, because we're disabling it, and we're using this thing called EV100, and you're like, what is that? EV100 is basically a standard for exposure value. So when we talk about exposure, remember, we're talking about the amount of light getting into a place. So there's an equation for this. It has to do with an aperture and a film speed and the ISO, so the sensitivity of the film. The long short of it is, right now, we're not adapting. So what does that mean? It would mean like in real life, if you went to a dark area, your eyes would start to adjust to the dark. It's kind of like when you go into a basement or a really dark spot at night. You can see pretty well at night, but if someone turned a bright light on, it would hurt. And like the same as if I would look out here, that would go down. If I put it back on, the default game settings, you can see it's starting to get brighter and brighter and brighter. It's kind of subtle maybe in the video, but if I come over here and I go in this dark area, it's starting to brighten, it's starting to brighten. And if I look back out into a bright area, it starts to bring down some of these other areas. And so it's this adaptive thing, which can be kind of bad at first. If you wanted to simulate your eyes, it's fine. Okay, so we're going to turn it off for right now. This will give us more calibrated results. So what are we noticing now? This is kind of like a camera at its most default settings. If you change this to 2, you have basically halved the amount of light that you saw last time. And if you set this to 3, it's half of the half. So it's quite a bit. So it's not linear, it's like multiplicative. So it's like, this is not only 4 times less light, it's half the light, half of that light, half of that light, half of that light. So it goes pretty quick. So at an EV of 1 or 0, we just doubled the light right now. And if we set it to -1, we just quadrupled the light. And now we just 8x the light. And now we just 16 times the light. So I like to set this to EV0. This is just a fast way to see if we have enough light in our scene, which you'll also notice if we go back to game setting, it's about right. The computer is trying to simulate that and get it around it, but leaving an EV0 will give us what we're looking for. And that's the fastest way for us to know. So if I take a look at this scene, we might ask ourselves, okay, what do we want to do now? Maybe I want to play with that directional light angle. I know before when we were testing it, I didn't want that slice coming in here, but there's something kind of maybe nice about a composition we could hook up. It's a little weird, this stops early. And I don't know what's causing that actually. Let's take a look. Huh. Oh, I know why. It's because it's turned. So the light was angled. If you look at this vector arrow, it was cutting in through here and it was actually being cut off by that corner, and that's why it was ending a little early. So I'm gonna rotate this so that we get more of that thing going on, and then light hits this a little more. I might drop it in so we still get some light here. And so we move the reflection probe and we move the lights. There's no way around it. With backlighting, you're gonna have to do this. Now, a couple things we can start looking into. The next thing I would look into is we changed temporarily on the lit mode right here. We changed from the game settings to EV0 so that we could control how much light was getting into our game camera eye. This is only for this viewport. I'm fairly confident we start to play. Oh, look, automatic exposure is all back through the game settings. And again, you're like, what's game settings? So how do we control that ourselves? What we need to do is we need to add a post-process volume, because under the hood, so I'm gonna come over here real fast before I get ahead of myself. Post-process volume, we just search for it. I'm going to left click, drag in the scene. You can see we get a box. Just kind of like our light mass importance volume, we have two options. One, you scale it and you make it basically the same size as your level as well. Make sure that it covers all of your level, okay, like that. Or, this is a little weird, we can set it off here, we can make it like infinitely small, it doesn't matter. And we set an option on it to unbound. And what does that mean? Infinitely extend. That means that this bounding box here doesn't matter. Right? Whatever settings we change now on this entity, its bounds don't matter. The settings are gonna work everywhere. And unless you have like a test case would be like, imagine you have like a tunnel in a level and you have like an outside on a level, and you want the inside of the tunnel area or indoors to like have a certain mood and look. And when you walk out into like the valley or the prairie, you have a different look. So that's when you wouldn't want to use unbound. But if your whole level has like the similar look, unbound is perfectly fine. So back to what we were gonna do. We were going to adjust, so we were going to help fix this auto exposure issue. And so if we click on our post-process volume, I clicked on it, we come over here, there's a couple options called lens for depth. We don't care about depth right now. Bloom, we don't care. Exposure, okay, we're on to something. So what is this set to? Well, in this metering mode, we have to turn it on so we can edit it. Set to automatic exposure right now. Let's not let it automatically expose. Let's set it to manual. Once we set it to manual, what we're gonna notice is a couple things. If I come in here, guess what? It's no longer doing adaptive eye. So we have to be in control of basically what it wants to do. And so from here, how we can adjust it, turn on exposure compensation. And again, remember how we were adjusting, hold on, this is being weird. Unbound, infinite bound, yes, oh, I know why. So if you were running this problem, we came in here, we set it to manual, we started adjusting this number, nothing's happening. And you're like, okay, Brad, I thought you knew what you were talking about. No, I do know what I'm talking about. The issue becomes, when we come back up here to this lit menu, remember we turned off game settings? Game settings was originally being driven by a hidden post-process volume by default. You have no idea it's on. If you were brand new, you would never have known it. By adding our own post-process volume to the level, we now are overriding those settings. So if I turn on game settings, we are now seeing what our post-effect volume is doing to it. So auto exposure histogram, manual exposure. Super dark. We'll fix that, okay? So what I like to do, come over here, set it to manual exposure. Now we have to ask yourself again, what is exposure? It's the amount of light coming in. We have an exposure compensation. So we have to say, well, how do we change how much light gets into the camera? And guess what? If you scroll down a little more, there's a camera setting. I don't want to get into too much of the technicals of it. You can totally look into this for yourself. But basically that EV100 thing we were looking at before, right here, it basically equates to an equation of, come in here, we turn on the shutter speed, we set it to 1 second. We set the ISO, I think to 800. I think that might be 100 actually, I'll leave that alone. Because the EV100 means 100 and the aperture to 1. This is now what's referred to as EV0. There is what is referred to as an EV chart. You can look into it, but it's basically the baseline exposure. It's neither plus nor minus the exposure. And what's kind of interesting about this is now, if we come in here and toggle game settings on and off versus EV100 at 0, so EV0 is what you would be referred to as. It's confusing, I know. You'll figure it out. But you'll notice that now they're 100% the same. So now we don't have to rely on this, and now we actually have the same thing happening in our exposure for our level. And from here, now what we want to do is a couple things. We can either change the exposure compensation, again, making sure we're using game settings. Come back to our post-process volume. I accidentally clicked off of it. Change our exposure settings. So this is a way to like dial it in. Basically the way I work, set this to 0, keep it there for as long as possible. If the scene is too dark, we need to ask ourselves, okay, where is the light? What are its settings? So we click on the light, we take a look at its settings, and we decide from there what needs to be brighter and darker. Now, another little secret that you'll get to find out today is the directional light. When we made this scene brand new, it's defaulted to 3.14. You might be asking yourself, why? The long short of it is, at EV100, or aka EV0, which is again what we changed our scene to, we changed it to EV0 by changing these values to manual and to changing the camera to 1/101, okay? In that sensibility, 3.14 is equal to basically the same intensity of the sun at 100,000 lumens. So the sun in the afternoon, the brightness of it in this value, lux, which I think is actually wrong. Don't know if that should say lux on it. That might be another Unreal lighting weirdness, because that's not, there's no way it's 3.14 lux. Anyways, think about it this way. 3.14, daylight, sun, mid-afternoon. You can go a little higher, maybe like 4 for like a brilliantly bright day. And again, this only matters on the directional lights, which makes it even more confusing. Every other light, my pro tip for lighting, add it in. I personally don't use candelas because it's the power in like a steradian. It's like a cone coming off this. I like to use lumens. So if you click on the light, right here is the intensity. If you, sorry, I kind of did it a little fast. If you're looking at it, there's this little arrow right here. It says show advanced. I open it up, set it to lumens. Lumens, the easiest way to think about it is it's the total energy this light puts off, which makes it kind of easy for me if you asked. So instead of having to do like 8, I just come in here and be like, okay, a normal like house light is between 200 and 800 lumens, okay? Again, kind of bright, but we need to bake it, do all those things. So we might be like 200 lumens, that's the total energy. The only thing that's unrealistic is if you look at any light in real life, the attenuation radius this isn't a thing that happens in real life. So if it's a baked light, your attenuation radius going all the way out is basically the equivalent of reality in a sense. Now, what makes it more confusing is the way that light falls off on objects. It loses energy as it goes, and you can kind of see that here happening in this. The reason why attenuation radiuses are a thing is it's a performance gain in video games. It's not a real life thing. There's no such thing as an attenuation radius on a real light. It just goes until it loses its energy. So I personally will tune this. Sometimes I'll go a little bigger. You can imagine even a candle would throw light pretty far. It is by default set up to so you use inverse square, which is good. Inverse square just basically means as the light gets farther away, it loses its power. So you can see now, right here, put it back to lumens. I don't know why it went to unitless. That was kind of weird. And I'll just kind of tuck it, maybe find somewhere cool to put this thing. Put it back here. Yeah, that'd be kind of cool, like a little light in that closet or something. I'm going to set it not to stationary. Stationary will just add a shadow mask and be useful for if we need to change that light dynamically. I'm just going to set to static right now and just kind of see what it gets us. So again, at this point now, you should be in a pretty good spot to do the rest of your lighting in your level. We talked a little bit about calibrating. We talked a little bit about putting your lights in your scene and calibrating them, thinking in terms of total power. Something to think about is a light like this. If you were to put a 200 lumen light at a football stadium, how far would the light go before it lost all its power? And the question is not very far, because it would be really effing bright. So if you're working with like a really big space, it'll feel really unintuitive because these bars only go so high. It's like 1200 or 1800 or something lumens. But like a football stadium light is like 200,000 lumens. So don't be afraid to come in here and like physically type in 200,000. Oops, kind of move some stuff. So now that this is done, if we come to decide if we like this or not, you might be asking yourself like, oh, this is really sharp. I don't like that. It looks really fake. And I would agree with you. And that's where we get into, first of all, it's stationary. We probably want this to be set to static. This will soften this out. If we needed the light to be able to turn off, which is cool because this information is saved into a mask, so we can turn it off. You can see it's not changing the GI, the bouncing light, but the direct light is definitely able to be turned off and on. Don't make that too big. What you'll notice is now there's another option in here called an area shadow. And you might be asking, okay, Brad, sorry, that was a little fast too. Use area shadow for stationary lighting under light mass. So if you scroll down, you would eventually find this thing called lightmass, and you would use area shadow for stationary lighting. So we're on a stationary lighting. We're using that setting. If we rebaked, what you'll see, what does area lighting mean? Well, it means that as this light gets farther away, it gets softer edges. And basically that check mark, when you turn that on, is going to enable this to kind of feather out a bit. The catch 22 on that is that it uses more texture memory because it has to have a bigger image for it to be able to get that kind of, let's call it fidelity. And so that's one way if you need to be able to keep it as a light that you can turn off or change its color. That's one way through this area shadow that you could increase its quality. So I think after we bake this, we'll take a look. If it looks like junk, whatever, we'll have to set it to static. That'd be my suggestion, unless we needed to change it. Yeah, it looks really low res, but that's because we're building on production. Oh, there it goes. So now you can see a little bit. See this feathered look? It's not great, but guess what? You can still turn that bad boy off and on. So if you needed to do more like you can't change the angle because it's baked into a mask. Basically, that's how we are getting this. But you can see if we made the bake higher, see how it's starting to give you this little gradation. It just has to make the texture wicked big to be able to do that. So if you're running out of VRAM or something like along those lines and you don't have enough texture memory, we might not be able to get away with it. But hopefully this gives you a primer into setting up some of your lighting. My suggestion would be just bake this bad boy on static. I think we'll do that real fast here and just kind of show the results, the difference. You got to see kind of what the quality in terms of at least preview, because remember, we want this bad boy to look better. You need to be coming in here and changing this to production. Preview is not going to cut it. It is fast, but it's not going to get you those super juicy, very realistic renders. And again, I think even this light, oh, I think we changed this to static, didn't we? Yeah, we did. And then you can see how this is starting to kind of soften a little bit too. It's the light, it's the penumbra, or whatever they want to call it. It's the long short is like, as a shadow is closer to something, less light will start to interfere with it, and the farther it gets away, more light will start to soften out a shadowed light. So you can kind of play with that. Now this should be done. Give it a second to think. It's stuck. And what you'll notice is, I think it's actually done. Oh, that was weird. Wait, did I change the right light? Let's just do a double check here. Because it looks like it's still stationary. No, that's baked, I guess. Oh, that's weird. Hypothetically, you wouldn't be able to, yeah, it defaults back to a real-time light. Yeah, so you can see we're getting a similar result now, baked. We don't have to pay as big of a cost because it's not actually a mask. This is just in the pixels. Another thing is to remember, if it's still pixelated like that, you need to come in here to your optimization views, light map density, and you would need to start cranking these even higher. I looked at some scenes where people were doing some really high fidelity stuff, and basically their light maps were really, really, really dense. The issue with that is texture memory again, so in a real-time game, you wouldn't be able to get that luxury. So something to think about. But anyways, hopefully this was helpful, and I will see you guys later. Let me know if you have any questions. Just ask them in the chat.